Hello guys, let us find empirical formula and molecular formula from percentage composition in 4 steps, and it is not as difficult as it appears. Let us read the question. A compound gave the following data: carbon 57.82%, oxygen 38.58%, and the rest hydrogen. Its vapor density is 83. Find its empirical and molecular formula. Let us make one table and give heading to each column. First column has element, second percentage composition, third atomic weight, fourth relative number of atoms, and fifth one is simplest ratio. First step is to use the information given in the question and fill first 3 columns of the table. We know elements: carbon, oxygen, hydrogen. We have their percentage composition. Percentage composition of carbon is 57.82, oxygen is 38.58, and hydrogen we have to find out. We know atomic weight of these elements: carbon 12, oxygen 16, hydrogen 1. Let us now find percentage composition of hydrogen. We can easily find it by adding percentage composition of carbon and oxygen and subtracting the sum from 100. That is 100 minus 57.82 plus 38.58, which comes to 100 minus 96.4, which gives us percentage composition of hydrogen in the compound is 3.6%. First step is over. Now in second step we have to find relative number of atoms. This can be done by using formula percentage composition divided by atomic weight. Some of you may find this step little tedious, but it has to be done, so do it calmly. 57.82 has to be divided by 12, 38.58 has to be divided by 16, and 3.6 has to be divided by 1. 3.6 divided by 1 will remain 3.6. Let us write answers of all the divisions: 4.8, 2.4, 3.6. Our next step, that is step 3, is to find simplest ratio and write empirical formula. To find simplest ratio, note down relative number of atoms. Select the smallest among these and divide all by the smallest one. 4.8 divided by 2.4 is 2. 2.4 divided by 2.4 is 1. 3.6 divided by 2.4 is 1.5. Simplest ratio represents number of atoms of each element present in empirical formula, which should be in whole number, but 1.5 is not a whole number. To convert 1.5 to whole number, we will multiply all by 2. So we have 2 2s are 4, 1 into 2 2, 1.5 into 2 3. We can now write empirical formula as C4O2H3. In step 4, we can find molecular formula using empirical formula and vapor density, which is given in question as 83. Let us clear this space for step 4. Find molecular formula, we need empirical formula weight and molecular formula weight. Let us find empirical formula weight, which is equal to 4 carbon, 2 oxygen and 3 hydrogen. 4 into 12 plus 2 into 16 plus 3 into 1, which is 48 plus 32 plus 3, which comes to 83. We have to now find molecular weight, which is equal to 2 into vapor density. That is 2 into 83. It comes to 166. Next step is to find value of integer n. N equals to molecular weight divided by empirical formula weight. That is 166 divided by 3, which is equal to 2. We got value of n equals to 2. Finally, now we can write molecular formula. Molecular formula equals to empirical formula with subscript n. N we calculated as 2. So molecular formula equals to C4O2H3 subscript 2. So all the atoms inside the bracket have to be multiplied by 2. Finally, we have the molecular formula of compound, which is C8H6O4. Let us solve one more numerical, relatively simpler than this one. The question is 4 gram of metallic chloride contains 1.89 gram of metal X. Calculate the empirical formula of the metallic chloride. We are given atomic weight of X equals to 64 and that of chloride equals to 35.5. Mass of metal given in the question is in grams. So we will make little change in the table. We will change percentage composition to mass in gram. 4 gram of metallic chloride contains 1.89 gram of metal X. So remaining part is chloride. So we can write mass of X plus mass of chloride equals to 4 gram. 1.89 plus chloride equals to 4, or chloride mass is equals to 4 minus 1.89, which comes to 2.11 gram. With the information now we have, we can fill first 3 columns. Elements are metal X and chloride. Mass in grams is 1.89 and 2.11. Atomic weight is given. Atomic weight of X is 64 and that of chloride is 35.5. Our next step is to find relative number of atoms. For that we have to divide mass in grams by atomic weight. For metal X, 1.89 divided by 64, and for chloride 2.11 divided by 35.5. Results of these divisions can be rounded off and written as approximate numbers. 1.89 divided by 64 comes to 0.03 and 2.11 divided by 35.5 comes to 0.06. Next step, to find simplest ratio, we first note down relative number of atoms. Select the smallest of the two and divide both by the smallest. That means 0.03 divided by 0.03, 0.06 divided by 0.03, and that gives us answers 1 and 2. We have simplest ratio of atoms. So empirical formula of metal chloride contains 1 atom of metal X and 2 atoms of chloride, X1Cl2. This can also be written as XCl2. Let us quickly solve one simple numerical which often comes in exams. And the question is, calculate molecular formula of a compound whose empirical formula is CH2O and vapor density is 30. To find molecular formula, we need 3 values: empirical formula weight, molecular weight and N, which is equal to molecular weight divided by empirical formula weight. Empirical formula of the compound given is CH2O. So it contains 1 carbon atom, 2 hydrogen and 1 oxygen atom. That is equals to 12 plus 2 into 1 plus 16, which comes to 30. So empirical formula weight is 30. Now let us calculate molecular weight. Molecular weight is equals to 2 into vapor density. That is 2 into 30, which comes to 60. Now let us calculate N. N equals to molecular weight upon empirical formula weight. That is 60 divided by 30, which comes to 2. Molecular formula is equals to empirical formula with subscript N. This is the formula to write molecular formula. Now N we got as 2 and empirical formula is CH2O. So molecular formula equals to CH2O bracket 2 as a subscript. That means we have to multiply all atoms by 2, which comes to C2H4O2. This is the molecular formula of the compound asked in the question.